Welcome to our guide on database normalization, focusing on achieving Voice Code Normal Form, or BCNF. We'll show you how to clean up your database design for maximum efficiency and integrity. Occasionally, when we design our database entities, relationships, and attributes, our tables end up with unwanted redundancy. This redundancy makes the data inefficient and significantly harder to manage over time, leading to potential inconsistencies. But there is a systematic way to fix this problem through database normalization. Normalization is the crucial process of eliminating this redundancy. It means decomposing a single cluttered table into two or more cleaner tables. By moving to a higher normal form, normalization ensures that your data is stored efficiently and is much easier to maintain. Database designers often aim to normalize tables all the way to Voice Code Normal Form, or BCNF. In BCNF, the main principle is this: if column A depends on column B, then column B must be unique. This is the final step of the logical design phase, ensuring robust and scalable database architecture. The normalization process starts with step 1, listing all unique columns within your table. These unique columns can be simple, meaning a single column, or composite, meaning multiple columns working together as a key. When dealing with composite keys, always ensure they are minimal. If any column is unnecessary to establish uniqueness, remove it. Next, in step 2, you need to identify any functional dependencies on non-unique columns. Look for attributes that are determined by or dependent on a column that is not unique. These non-unique columns could exist entirely outside of any unique key, or they might be part of a composite unique column. Finally, we move to step 3. Eliminating those problematic dependencies to reach BCNF. If column A depends on a non-unique column B, move column A into a brand new table along with B. In this new table, B becomes the primary key. In the original table, B remains, but is now designated as a foreign key. This technique of decomposing the table is key to ensuring data integrity. Because the relationship between A and B is perfectly preserved in the new table, absolutely no information is lost during the normalization process. The result? A database that is cleaner, much more efficient, and significantly easier to maintain and scale.
So we are looking at data engineering and we are focusing on normalization. So we have a shipment table here that has a tracking ID, an order code, a product number, a product name, a shipper code, and a shipper name. So the first question is, which simple or composite column are unique and minimal? We've been given the list of all the columns that we have been given. The tracking ID only is the tracking ID and the order code column. along with the product number? Is it the tracking ID along with the order code, product number, and shipper code? So let's start with this question. As you go on, you can select the right answer. So, what looking at these options over here, it gives us an idea. First, we need to understand what is unique, what we mean by unique, and what we mean by minimal. Okay. So, the key concept here is unique. So, unique refers to the columns that can uniquely identify each row in the table. Minimal means it has to have no subsets of those columns and can still uniquely identify rows. That means we don't have redundancy. Then, in this case, a candidate key must be both unique and minimal. That means it should uniquely identify each row in the table and still have no redundancy. That means it should not have subsets. So when you're looking at option, let's start with option C, tracking ID and order code, product number, shipper code. So it is unique. Why is it unique? Because it is a unique identifier. Like it's more of a primary key. Yeah. It is unique because it can identify each row in the table. Okay. But it's not minimal because tracking ID alone is enough. Yeah. It is not minimal because it has redundancy. Yeah. It has redundancy. Okay. Let's look at option B, tracking ID along with order code and product number. So this combination is actually very unique, but it's not minimal because tracking ID alone already suffices. So adding extra columns make it redundant. So this one is not minimal. So we remain with option one. So tracking ID alone is designed as a unique identifier. That is a primary key. It alone can uniquely identify each row. Incorrect. So we were wrong because tracking ID is a primary key but not the only unique column. Now let's look at option B. It is correct, tracking ID and order code and product number. So tracking ID is unique. Data in the table suggests that order code, product number is also unique, but this should be confirmed with database users. Okay, so the idea is tracking ID is unique, but data in the table suggests that this is unique and this is also unique. All right. Now, option C is incorrect because order code, product number, and shipper code are unique, but they are not minimal since shipper code is probably not necessarily for uniqueness, right? Okay, so we are here with our option B. Let's go to the second question. Which columns depends on part of a composite unique column? Is it which column depends on part of the composite unique column, order code, and product number? So we have product name, we have shipper code, and shipper name. Mhm. I will say product name. Why? Because it's the product name depends on a product number. Sleep sandal are related to 8024. Shirt is related to yeah. Now we were saying the shipper code and shipper name are more together. I think they are more dependent on the tracking ID, right? So which column depends on a column that is external to unique columns. Okay. Is it the product name? Is it the tracking ID? Is it the shipper name? Okay, let's eliminate the product name because the product name is related to the order code and the product number. Tracking ID is external because shipper name is us giving it the shipper name. The tracking ID is more of an external to this. Incorrect. Okay. In this case, it's not product name because the Federal Express ships three different products. So product name does not depend on shipper code or shipper name. Tracking ID is incorrect because their primary key is unique and therefore depends only on other unique columns. Okay. Shipper name is correct because it depends on the shipper code. Let's get to question 4. When shipment is normalized, which columns remain, right? Remember what we did up there concerning normalization, where we normalize this column, and what columns remained were registration code, student ID, and course number in term, because these were not unique minimal. So in this case, if we have our minimal and unique columns as tracking ID, order code, and product number. So we have tracking ID, order code, and product number. That means that these will remain. What do you think? Put in the comment section. So we will have our okay, let's see. Is it the order code, product number, and shipper code? Is it the tracking ID, order code, and product number? Is it the tracking ID? So you remember the tracking ID is unique. So anything with the tracking ID we eliminate. So I'll go for C. Mhm. Tracking ID is unique. That's true. All unique columns remain when shipment is normalized. All right, now I get it. So all unique columns were tracking ID, order code, and the product number. So this, I think I thought which one will not be normalized. If we were looking at which one will not be normalized, we'd be going for C. But which will be normalized or which will remain, I will go for A because tracking ID, order code, product number, and shipper code are non-unique columns and are removed from shipment. All other columns remain. Now, it will not be B because shipper code is dependent on both unique columns and remains when shipment is normalized. Okay, so we go with